Hello.
Subrata sir, hello.
Hello. Hello.
Yes, sir. So yes, sir. Subrata sir has joined, sir.
Okay. Then uh, 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 all the organizers and also I have with us already just our HOD, Department of Computer Science and Engineering. So can you start, ma'am?
Yes, sure. So, eminent speakers have joined us. A very warm welcome from the department and as well as being part of organizing committee. And thank you very much for accepting our invitation. So, hope to have a great session ahead. Thank you.
Okay, welcome you all. I am Dr. Sujay Mistry, Assistant Professor at Department of Computer Science and Engineering, MAKAUT. I am going to host this today's session. We have already seen that all the eminent speakers, today's eminent speakers, both the speakers have already joined. So let's not then my voice start the session as early as possible. So first in the first session, we have with us one of the eminent speaker who have agreed to speak his voice in this session, Dr. Subroto Datto. I just give him a small overview about Dr. Subroto Datto. Dr. Subroto Datto is currently working as an assistant science and engineering, NIT Jamshedpur, India. He has completed his master's and PhD from Jamshedpur University. He is the recipient of the Enormous Mundus postdoctoral fellowship. He has completed his postdoctoral program from University of West Scotland. He has more than 6 years of teaching experience. So welcome you, sir, and welcome all the participants. Hope you will enjoy the session. Let's start.
Thank you, Sujay, for your introduction. So we have shared the screen, right? Is it visible?
Yes, sir. It is visible, sir.
Okay. So today I would like to say something about IoT application and security. I am Dr. Subroto, as told by.
Sir, your voice is getting sir, not audible so fully.
Okay.
Yes, sir. Yes, sir.
Today I'll start topic that IoT and its application and security. I'm Subroto Datta from Department of Computer Science, National Institute of Technology, Jamshedpur. This is today's agenda: IoT definition, revolution of technology, smart system and IoT, sensor, actuator, connectivity, people and process. Next is why security needed in WSN, different challenges of sensor network security, different condition to implement a security system in WSN, different types of attacks, and defensive measure conclusion. So the Internet of Things is a network of physical object that contains embedded technology to communicate and sense or interact with the internal states or external environment. It built by many cutting edge technology like sensor, actuator, using machine learning, using security aspect, many things. It has different types of application area, more or less all over the uh, various type of application area, maybe the agriculture, automation, uh, energy consumption, security, surveillance, uh, etc. So revolution of technology, uh, how technology revolute. Initially it was IT, information technology, then it was the web technology in 2000, then it was the e-commerce in 2005, then it was the digital marketing, then it was the digital business 2015, and in 2020 it was the IoT automation enterprise. And initially it was the people, uh, operated by people, and next is it is a people and business, next it is the people, business, things and smart machine. And initially it was the human only, next it is the human and data informed, next it is the machine assisted, human plus machine assisted, and next is the machine only. uh, we In the y-axis it is the intelligent, and x-axis it is the automatic. Initially human need to apply more intelligence to serve a job. By the time we are going to the era of automation. In case of automation, the human intelligence is replaced by the machine intelligence. So there are different kinds of IoT product. It's like a smart socks to measure running from connected water bottles. A person water consumption may be measured by the intelligent water bottle. If you are not consuming enough water, that will be notified you uh, through the smart technology. So internet connected e-cigarette. So if you are consuming uh, more cigarette, then that will also be uh, notified by the technology. Sonic toothbrush by Colibri includes 9 motion sensor and an algorithm designed by 5 mathematicians to identify which quadrant of the mouth a user is brushing. Uh, the Mimo baby monitor is a body suite that monitors a baby's body temperature, motion, and breathing pattern. Sleep monitors, e-textile, blend fix sensor, electrode technology, or simply sensor equipped. So IoT is everywhere. Different, I told you, different, our whole society is connected with somehow the IoT technology, and will be connected. In the first world country, they are already acquiring the technology, but in our country, we are still not in that much of automation. But we shall introduce the automation uh, day by day, such as agricultural sector, security, smart lighting, smart building, predictive analysis, asset tracking, connected street light, intelligent routing, connected cars, wearable, road tolls, etc. Everything can be automated by the IoT, Internet of Things. This is a market of IoT. This particular graph shows that how IoT is using by different country, whereas in India it is very low. Uh, Therefore, and India is one of the most populated or second populated country. Second most population is in India, and therefore there is a scope of IoT to use in our Indian, not only India, but also various other country also can acquire the technology by that time. Smart system and IoT. So IoT is basically a combination of sensor, actuators, connectivity, people and process. Sensors is a and actuator is a nervous system of the IoT. Connectivity carry the signal, and people and process are connected to each other by using those systems. So we are giving our world digital nervous system. The location data using GPS sensor, eye and ears are using cameras, microphones along with the sensory organs that can measure everything from temperature to pressure changes. Uh, the figure shows the different kinds of sensor available in the market. There are machine vision, ambient light sensor, position, presence, proximity sensor, motion, velocity, displacement sensor, temperature, humidity, moisture, acoustic, sound, vibration, chemical, gas, etc. So different kind of sensor can act over the top of different IoT application. There are different type of sensor there. That is a vibration sensor, chemical sensor, humidity, tilt sensor, pressure sensor, temperature sensor, motion sensor, proximity sensor, optical sensor, acceleration sensor, flow sensor. Actuators. What is actuators? Actuators is sensor will send something through sensor. The agent means that particular system will send something, and through the actuators it will give the output to the environment according to the sensed data. Okay, so suppose light emitting diodes, LED relays, motors, linear actuators, lasers, speakers, LCD plasma display, etc. These are the connectivity, different types of connectivity technology can be used in different layer of IoT. Suppose based on the requirement of different layer, we can use different uh, different frequency level of connectivity area, like a PAN, LAN, MAN, and WAN. PAN is a personal area network, that is basically Bluetooth 802.15. LAN is a local area network 802.11. IEEE 802.11. MAN is a metropolitan area network 802.16. One is a wide area network 802.20. And at the different for the different level, we can use different types of connectivity technology, like power line Ethernet printed, Bluetooth, Z-Wave, ZigBee, 6LoWPAN. 6LoWPAN. 6LoWPAN is a modified version of IPv6. And license-free spectrum, 2G, GSM, Edge, CDMA, eVideo, 3G, GPS, GPRS, etc. The embedded system can use the range of connectivity to connect with other devices of the internet. Some examples are below: Wi-Fi, Bluetooth, RFID, Zigbee, NFC, Ethernet, LTE, 3G, GSM, CDMA, etc. People and process. The information transmitted via chosen connectivity can be used by people and process to take action or retransmit the info to a different embedded system to be used to perform an action using actuators. Below are some examples. A gas leak, a smoke is detected by chemical sensor, and the info is transmitted to monitoring center. Help is dispatched immediately, and the affected are informed. A home security system detects intrusion. A call is placed to the authorities and owners altered. Help is dispatched. Load sensor can initiate the communication to the supplier to send more stock, enabling and supply chain management automation. Car can be sent diagnostic to service center, and service center schedules a repair. Suppose if you don't have any, if you have lack of uh, petrol in the car, the self-driven car can go automatically to the petrol pump, and after filling up the petrol, and you can go away. So your IoT thermostat send the information to the cloud, which can be analyzed to manage your energy expenditure. So now creativity, creating new types of smart application. These four types of things can be combined together. That is a sensor, connectivity, people, and process that has already been discussed. So compound application. So different IoT application is not independent. They should have relation between each other, because suppose you have a home application. Home application is related to the waste management, is related to the healthcare, is related to the office, is related to the transport, waste management, health is related to the transport. So in this way, we should have handshaking between different types of application. Compound application, suppose uh, Sophia and her son Luis are on the way downtown for an appointment. So what happened? Wireless sensor embedded in the parking lot of helps direct the car to an open spot in the city. Will also initiating the parking fee. Using the car's parking details, the vehicle schedules a mobile machine to change the oil while two are away from for the afternoon. So in downtown San Francisco, 20 to 30% of the traffic congestion is caused by the people hunting for parking spot. So in order to avoid this kind of uh, traffic congestion, we can take help of the IoT application. The technology will tell you in which direction you may go in order to avoid the traffic congestion. Healthcare plus smart home. Aging Uncle Earl is still living isolated at his home, and you are concerned about his safety. So 40 million adults age 65 and over will be living alone in US and Canada and Europe. So wireless sensor throughout his house help measure healthy activities level, sleeping, pattern, medication schedule, etc. So if there is any anomalies in his normal activity, that will be reported to the healthcare center, and according after the after the report, the rescue team will come and they may give some help to the elder people. Smart building and mobility. Smart building and mobility. Anna is being pressured to reduce her company's expenses for their new corporate office. After speaking with the expert, she decided to install sensor to automate energy usage according to building occupancy, people flow temperature, and other ambient condition, improving the building's overall efficiency. So energy used by commercial and industrial building in US creates nearly 50% of our national emission of greenhouse gases. If we can avoid this, that will be a great help for the environment of our society. Industrial revolution. There was first industrial revolution was that was named as a wave 1, wave 2, wave 3. So wave 1, machine and factories that power economics of scale and scope. Wave 2 is a computing power rise of distributed information network. And wave 3, that is a era of IoT, the machine-based analysis, physics-based deep domain expertise, automated predictives. So in the wave 3, that is a industrial internet. That is basically industrial internet of things. This is the size of the IoT market. Size of the industrial IoT market by 2020. That is a 90 billion to 110 billion by 2020. That is Morgan Stanley's report. Industry ARC 2016. Industrial IoT market by 2021. That will be 123 billions. Impact on global economy by 2030. So Accenture estimates industrial IoT could add 14.2 trillion to the global economy by 2030. So global industrial IoT market reports global IoT market to grow at, according to the CAG report, 7.3% until 2020. So this is if this is the size of the business, then obviously we need to secure this business. We need to ensure the security of each and every level of this particular different types of IoT technology in different level. This is a different layer of IoT technology. First is the application layer that present the visualize the finding, a key performance indicator, open ecosystem for partners and suppliers. That is a visualization. Next is the operation and control the IoT infrastructure, central data storage, contextual enrichment, big data analysis, and deep machine learning, turning data into insights, turning insights into business transformation. So this is the cloud and IoT cloud or platform. Next is the connectivity, ubiquitous, reliable and secure communication technology for all endpoints and edge devices. Next is the edge computing. processing unit sitting on the same physical entity, turbine, airplane, building as IoT endpoints, translate the IoT OT of protocol to an IT product, TCP/IP, ingest and pre-process the data, so also called edge analysis or real-time analysis or in-band analysis. Distributed sensor, this is the uh, lowest physical, you can say the physical layer of the IoT. This is a sensing layer. Sensing layer is basically different kinds of sensor are distributed among the application area, and those sensor collects the data, uh, collect the data and send to the base station, and according to the sensed data, the technology will, the system will analyze the data, and according action will be taken. According action will be taken based on the aggregated sense data. So IoT, there are different kinds of IoT security risks. That is a disruption and denial of service attack, understanding the complexity of vulnerabilities, IoT vulnerability management, identifying, implementing security control, uh, fulfilling the need of security analytics capabilities, modular hardware and software components, rapid demands of bandwidth requirements. So there are thousands different types of sensors is spreading in the IoT application area, and different type of connection is required to communicate from one layer to another layer. So the demand of bandwidth is very high. That is also a problem. Modular hardware and software components. Modular, so one layer hardware and software has to be handshake to the other layer. So the modulation is needed to make them understand what is the message is coming from one layer to another layer. So why now security is needed in each and every layer, as because and security also needed for the WSN layer also, and because the data which are collecting from the environment, if that is wrong data, then the analysis will be wrong, then the action taken based on those analysis will also be wrong. So in this way, therefore we need the security in the wireless sensor network layer. But the problem is that, so there are different points. That is a battlefield disaster. In the battlefield, we can easily know the activity of our enemies using the wireless sensor network. Disaster, protect the location and status of casualties from unauthorized disclosure, particularly if disaster relates to ongoing terrorist activity. Public safety, false alarm about chemical. If there is a alarm is ringing in the false cause, the biological or environmental threat could be cause the panic of disregard for warning system. the home healthcare, because protecting privacy in paramount. Only authorized user can query or monitor the network. There are challenges of wireless sensor network security. The limited resource, node deployment. The resource is very limited because the wireless sensor node is tiny, and it uh, has limited computational power, limited memory, limited bandwidth. Everything is very limited. Node deployment. So while you are going to deploy the node in a hostile area, that is not a very not only that you have to deploy the node in a hostile area, but also you have to keep in mind the deployment strategy also. So that the sensing will optimize by the node deployment strategy. Scalability. So you are using thousand number of sensor nodes. Therefore, it is very difficult to manage many number of nodes are communicating with each other, and there may be some suppose you have to give the each node the identity or ID of, you have to ensure the ID of each node. You have to ensure the security and safety of each node so that the data is not compromised. You have to ensure the bandwidth for the each node. That is the scalability is also a problem for the WSN security. Node dynamics, unreliable transmission media. So transmission media is very maybe the unreliable. Some other person may listening what you are sending from one node to another node. Low bandwidth. Bandwidth is very low. For the low bandwidth, the message passing is also not very efficient manner. Erroneous sensor reading. So sensor reading may be the erroneous due to the lack of efficiency. So requirements to implement security system in WSN: data confidentiality. The data, we should ensure the data confidentiality. Data should be confidential. Data integrity, freshness. Data freshness. Freshness means that data should be suppose one particular sensor node is collecting data from the environment, and it is sending data to the base station, and that data should be real-time data, or not a very old data set. Availability of the bandwidth should be available. Self-organization. If there is any changes in the network, that should organize selfly. Time synchronization. While communicating one node to with another, time should be synchronized. That while one node is talking, another node should listen, and another for another, while the second node is talking, the first node should listen. In this way, the time synchronization is a requirements to implement the security system. The secure localization. So localization is an important factor for the security system because the location, to the location, we may identify a particular node. We may identify a particular node's identity. Next is authentication. different types of attacks in WSN layer. First is the denial of service attack. Denial of service attack is a node is spreading lots of message to the malicious node, lots of message to the network, so that the network become very busy, so that the actual node will not actual communication will not happen. Sybil attack. In case of Sybil attack, uh, a node of a particular location may be pretended as different location of the node. I mean, for a particular node A is the telling you the location, particular location L1 can be compromised by the malicious activity and can send you the false location. The traffic analysis attacks, node replication attack, attack against privacy, and physical attacks. So cryptographic authentication and time of joining. There are obviously, you know, that there are two types of cryptography. There is a public key and private key. And in case of private key, it will be the private or secret key is encrypted or decrypted key known only to the party or parties to the exchange of secret messages. Suppose DES is a system, public key, that is the RSA, and elliptical curve cryptography. Public key cryptography, also known as asymmetric cryptography, is a class of cryptographic algorithm which requires two separate keys, one of which secret or private, or one which is public, although different. Two parts of this key pair mathematically linked. So first is the denial of service attack. DOS attack is attempt to make machine or network resource unavailable to its intended user. Simple form radio jamming, sophisticated form transmit while a neighbor is also transmitting or continuously generating a request to send signal. Possible solution: detect jamming, map the affected region, route around the jammed area. Avoiding the jammed area. Attacks on physical layer. Jamming, the difference is a spread spectrum, that is a frequency spread spectrum. Region mapping, less expensive. So tampering defenses. Tampering means your data is changed from one particular data is compromised, and it will be changed the content of the data. So defense, tamper proofing, hiding, etc. A link layer, that is a collision. Use error correcting codes. So if there is a collision of message, then through the error correcting code you can rectify it. Network and routing attacks. Neglect or drop packet arbitrarily. Solution: send multiple message through multiple path. Misdirection. Forward message along wrong paths. Solution: authorization and monitoring. Black holes. Black holes is a particular area, energy is consumed. That particular area is create a black holes. So so if a particular message can enter into the black hole region, then it cannot go to the base station. So redundancy, we can send the data through different path. transport layer DOS, flooding. An adversary sends many connection established requests to the victims. Each request causes the victim to allocate resource that maintain state for that connection. Solution client puzzles. Server distribute the puzzles uh, and client wishing to connect most must solve and present the puzzle to server before receiving the connection. Make an adversary to commit resources. Sybil attack. In case of Sybil attack, the malicious node possesses the multiple identity. During the routing of data message, it overhears that message from the neighbor node and transmit it to the network multiple times with different identity. The actual node receives and transmit those message, which results the unnecessary energy dissipation and jamming the network. Data aggregation. By using the Sybil attack, one malicious node may be able to contribute the aggregate many times. Voting. Wireless sensor network could use voting for a number of tasks. The Sybil attack could be used to stuff the ballot box in such in any such votes. Unfair resource allocation. The Sybil attack can be used to allow a malicious node to obtain unfair share of any resource share. Solution. There are two methods to validate identities: direct validation, indirect validation. Indirect validation, the trusted node directly tests where that the joining identity is valid or not. There will be the trusted node that will validate that if a node joined, that is a whether the genuine node or the compromised node. The second type is indirect validation, in which node that have already been verified are allowed to vouch for the for or refuse other nodes. So a particular node that has already been verified, that can be used as a trusted node. Using this node, a node verification can be done uh, uh, for the nodes which are joining current time. Radio resource testing. As a form of resource testing, this approach relies on the assumption that any physical device has only one radio. Also assume that a radio is incapable of simultaneously sending or receiving on more than one channel. Consider that node wants to verify that none of its neighbor are Sybil identities. It can assign each of its n neighbors a different channel to broadcast some message on. It can then choose channel randomly on which to listen. Right? Suppose that S of the verifiers in neighbors are actually several nodes, and in that case, probability of choosing to listen to a channel that is not being transmitted on, and thus detecting Sybil node is S by n. Conversely, the probability of detecting Sybil node is n minus S by n. If the test is repeated for R rounds, then the chances of number of Sybil node being detected is n minus S by n to the power R. Suppose that in a node that's set of n neighbor, there are Sybil nodes, M malicious node, and G good nodes, correct nodes. Of this, a node can only test C neighbor nodes at one time. Of these C neighbor nodes, there are S Sybil nodes, M malicious node, and G good nodes. So the formula is given here for determination of a particular node is Sybil nodes or good nodes. What is the probability of that? traffic analysis attack. In this attack, the attacker disabled the base station and the malicious node accept the data instead of base station. The nodes which resides nearer to the base station forward more data packet than the nodes which away from the base station. Therefore, the approximate location of the base station can be easily identified by the packet delivery ratio. Solution: the nodes which are wish to send a packet to the base station, it's sent to the multiple parent nodes towards the base station. So it can send multiple parent node so that the malicious node cannot identify which one is the actual base station. In the random walk, when a node receives a packet, it forwards the packet to one of its parent node with some probability. So fractal propagation technique, several fake packets are created and propagated in the network to introduce more randomness in the communication pattern. But problem is that in that particular, all the solution is a energy consuming solution. So it will consume unnecessary energy in order to avoid the malicious node. This is the scenario. First figure is the shortest path. Sensor node is sending data to the base station, the shortest path. Next, the multipath, it is sending the base station to the multipath. So multipath routing plus random walk. It is more energy consumable solution. That is, it is randomly sending data from one node to another. In this way, the message will forwarded to the base station, but the path distance becomes maybe very high. And next is the multipath routing plus random walk plus fractal propagation. Some data packet is propagated that is not needed into the direction of not in the base station but also different than the base station, so that some randomness can be invoked in the network while sending the data packet. Node replication attack. In this attack, a node replicate a node of an existing network with the same node ID. The replicated malicious nodes push the false data to the network, which results the system becoming ineffective. Node replication, the different nodes replication detection technique. So central detection, each node sends its list of neighbor nodes to central base station. The base station searches list for replicas. Disadvantage, the single point failure, the exhaust nodes near to the base station. Each node sends its list of neighbor to a central base station. Base station searches list for replicas. So exhaust node near to the base station and make them from the target. Some application may not use the base station. Localized detection. The neighborhood use the local voting protocol to detect the replication. Disadvantage, the replication is a global event that cannot be detected in a purely local fashion. Distributed approach. Each node floods the network with its location information. Each node stored the location information of its neighbor. If it detects a conflicting claim, suppose a node of having 2 ID came to a particular node, then obviously their claim is defective claim, and that particular node will be revoked from the network. And advantage, achieves 10% detection of duplicate, 100% detection of the duplicate nodes, assuming the broadcast reaches throughout the network. If the network is connected, disadvantage, the disadvantage is a energy consumption. Again, each node's location broadcast require order of n messages. So total communication cost is order of n square. So that requires huge amount of energy. Different node replication detection technique, deterministic multicast protocol. If node broadcasts its location claim, which is sent by its neighbor to a set of deterministically chosen witness node. Witness are chosen as a function of node ID. If a node is replicated, the witness will get more than one location claims for a single node ID, which can be then revoked. Line selected multicast. Location claims from node alpha to gamma travel through several intermediate nodes as well. If the intermediate node stores the location claim, then the line is effectively drawn through the network. If a duplicate location claim crosses the line, it detects the revocation scheme is invoked. So only need a few lines to detect duplicate location claims. Suppose this is a figure, this is a scenario. Beta, a particular message is going to from beta 2 dash to gamma 2 dash and beta 3 to gamma 3. So in the point of sigma, they are getting two several, if that particular node getting a two several messages from this particular two several messages from this particular point, this particular point. So what is the thing? If location claim from node alpha to gamma travel through several intermediate node as well. If the intermediate node stores location claim, then the line is effectively drawn through the network. If the duplicate location claim cross the line, it is detected and revocation. So therefore, if this particular beta 2 dash and gamma 2 dash are the duplicate nodes. So the duplicate node crossing this particular line, and this gamma 3 and beta 3 are the real node that is crossing also this particular sigma point. So if both are crossing the same point, that is basically we can say this is the we can identify these particular nodes are compromised. Secure broadcasting micro Tesla, timed efficient streaming, loss tolerant authentication. Problem: broadcast authentication, base station to sensor node to neighbor. So main idea is the base station computes a MAC message authenticated code with a key unknown to the sensor. The base station sends and sensor receives the message with the MAC. Later, the base station discloses the key to compute the MAC. Every sensor can now verify the MAC. If it is correct, that the sensor knows that the message was sent by the base station. Okay. And assumption, loose time synchronization between the base station and sensor. Each sensor knows the upper bound of the maximum synchronization error. Every node's aware of key disclosure schedule. Initial secret between the base station and each sensor to boost up the whole mechanism, the node key. So this is a Tesla keys are consecutive elements in one way of the key chain. So this is a key chain. One key is computed by the another key. The setup K initially the K0 is sent to each sensor, which using initial secret between the base station and sensor. The time is divided to epoch. Each message sent in I is authenticated with KI. So my KI is disclosed with epoch I plus D, where D is a system parameter. KI is verified by checking f of KI is equal to KI minus 1. So in this way, we can compute the key. So for a particular time domain, for a particular time quantum, the key will be same. That initially K0 for packet P1 and P2, the time quantum 2, the key will be K1. For packet P3, the key will be K3, etc. This is the conclusion. So we are approaching for the automation, but the problem is that there are so many problems in order to do the automation or in order to involve the IoT system because of there are so many challenges is there. There is a rise of botnets. What is the botnet? In the recent years, there have been increase of botnets among the IoT devices. A botnet exists when hackers remotely control internet-connected device and use them for illegal purpose. And enterprise could have their device co-opted as part of a botnet without any acknowledge of it. The problem is that the many organizations lack of real-time security solution to track this. Mode of IoT devices. So IoT devices is increasing enormously. So therefore, today there is a proliferation of IoT devices. There are over 7 billion devices around, and that number could be increased to 20 billion by 2030. More IoT devices means the increase of security vulnerabilities across the enterprise, and it is a growing challenges for the security professionals. And lack of encryption. Lack of encryption means that our encryption is a great way to prevent hackers from accessing data. It is also one of the leading IoT security challenges. These devices lack of storage and processing capabilities that would be found the traditional computer. Anyway, we are running out of time, maybe. So outdated legacy security, weak default password, unreliable threat detection method, small scale attacks in IoT, phishing attacks, inability to predict threats, infrequent updates, and there are lots of challenges in wireless sensor networks domain also. Wireless sensor network is an application specific field, different application demands different types of things over different issues. Depending on the types of application, different issue gets a different priority. Secure data transfer is one of the important issue in case of WSN. Depending on the relative priority with respect to other issues and types of application, there may be different level of security arrangement. And,
Sir, your voice is very low, sir. It is coming very low, sir.
okay, okay. Just this is a reference, and thank you.
Sujay, sir. Sujay sir, hello. Thank you, sir, for your valuable speech, sir. And, Sujay sir, hello. Sujay sir, are you there, sir? Hello.
Yes, yes, I'm hello. Okay. Okay. So, so there is two question actually. Uh, 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 First of all, thank you, Dr. Subrata Datta, for your brief and uh, knowledgeable speech and discussion. I hope every participant will be uh, learn a lot of you from. Uh, and there is actually two questions I can see from the question answer section. So in a short, we can discuss those two questions. First question is how to secure the handoff zones where the mobile sensor is toggling between the two zones. Some Pratik Bhattacharya actually asked this question. Uh, Specifically, I think what I might the handoff zones. He's asked about the handoff zones. So this is the
Uh,
first question.
so hand up zones means how to secure the hand up zones where the mobile sensor is toggling between two zones. Actually, if we can elaborate the question, that will be better. Toggling between two zones means.
I think it is asked by someone Pratik Bhattacharya. Is he there?
Yes, sir. We can allow, sir. We can allow
Yeah, yeah,
Pratik
yeah, yeah,
Bhattacharya if he
yeah.
is available.
He also asks another question also from his side. So
Okay.
So,
it will be better
Pratik
from his side.
Bhattacharya, please unmute your mic and please.
Can you hear me, sir?
Okay,
Yes.
Pratik. Yes, yes.
Yeah. Yes, Surya sir, it's me.
Yeah.
Okay, actually, this is not exactly related to WSN. It is more related to manets. So, where the host is allowed to move from one zone to another. So, when the zone change happens, so it
Yeah.
is sometimes in this zone and sometimes in that zone. So, that is the handoff zones. So,
Okay. I understand.
how to secure that borderline?
Yes, that is a synchronization problem will be there.
Yes, sir.
Synchronization problem will be there. That is a thing. I don't have any idea.
Okay, sir. Okay.
Yeah.
Sujay sir, you can ask this next question.
Yeah. Next question is it always possible to use ECC on low resource sensor nodes?
No, it is not possible.
Yes, sir.
It is,
That's what
it
I
is
was
not.
thinking, because ECC is a resource only thing. So,
Yeah. It is not possible. It is because computational power is very low.
yes.
Yes.
Okay, sir.
Okay.
Okay. Okay.
Then you can mute myself.
Okay. Then thank you, Dr. Subrata Datta,
Thank you.
for your knowledge, for your speech. Hope we will all meet during the pandemic situation. Other than this virtual environment, it is not possible for us to directly interact with the students physically. Uh, Hope you in the future. Not only hope. I expect that you join us in our campus, and we can will be making another FDP where you physically give us like this today's. Uh, today's whatever the speech you have done. So uh, now we can move to the next session.
Okay.
Uh, Thank you, Subroto. Thank you.
Okay. Okay. Thank you. I'm leaving.
And now in the next session, we have with us Dr. Fidus. So I think he's not joined yet.
Sir, yes, sir. Sir is now, I think, joining. Yes, sir. Sir, can you check it from your end if Firdaus sir is joining or not?
Okay.
Because he has some
Just
connectivity problematic.
actually, at the beginning, he has already told me that.
Yes, yes, and
he-
that's why, sir, if
he
you
has
can
some-
recheck it once. Sujay sir, is Firdaus sir able to get connected?
I've asked him, and he joins me. Actually, he's having some problem. That's why.
Okay, sir. Okay, sir. We are trying to get connect to the Firdaus sir. Please wait for a few moments. We will be soon getting connected to Firdaus sir. Suparna ma'am, we are getting connected to Firdaus sir.
Yes, sure.
Firdaus sir
Okay.
is having some problem of network connectivity.
Yeah, I have
Sujay
heard.
sir is trying to
He will.
getting connected.
Yeah, he will be delivering in very difficult time.
Yes, already told that he is coming some
Yeah.
problem.
Yes, yes, yes. Yes,
Yeah.
sir.
So it's fine. We are waiting. No issue.
So I asked him, he joined soon.
Dear audience, Firdaus sir is joining very soon. Kindly bear with us.
So producer is it joining? Ma'am. Second sir. Producer is joining. Has
Yes.
joined already.
He has joined though.
Yes, yes.
So
Okay.
that's why I told. Yeah.
Good evening. Just
Good
allow me
evening.
another a few seconds to set up my slides.
Yes,
Yes,
yes.
sir, yes,
We
yes.
are eagerly waiting for you.
Yes.
We are eagerly waiting for your speech. আমি ঘুমাইনি না
Shaikot sir, please mute yourself.
Okay, so I am all set. We can start. Let me know if you can see my screen.
Yes, yes.
yes yes it is
Dr.
visible.
Sujay.
He joined. Yeah, welcome to the FDP. So
So welcome.
Thank you very
sir.
much.
And now we can start our safety session. Sir, go ahead.
Sure. All right. So my name is Firdaus, and I'm a faculty member in the Department of Computer Science at IIT Guwahati.
Sorry, sir. Sorry, I am just.
Pardon?
Sorry, sir. I am just interrupting. As the time is just going through, I just not giving you the briefing.
No, that's fine.
Yeah.
That's perfectly fine.
That's a. Okay.
That's fine. So, some of you might be knowing me, and most of you not. Actually, I'm a person with background and 50% academic background, academics and research. So I'm kind of a mixture of both worlds. So I will try to talk. Perspective. My target today is to discuss the issues and challenges specifically with IoT protocols. That what kind of security issues we face and how do we actually deal with such situations. So I understand this is slightly a challenging thing to attend for attendees specifically. It's easy to speak in webinar because you don't see anybody, you don't get scared, and you go at your own pace. And for attendees, it's slightly difficult to relate. Nevertheless, I will try to keep it as fluid as possible. Feel free to ask any question in between or at the end, or you can put the questions in the Q&A, and I can try to answer at the end of the session. Either way, it works for me. So the agenda is very simple. I will try to discuss a little bit like how secure the IoT is, what are the issues and vulnerabilities that are in IoT, and key aspects for securing IoT solution. So I'm not speaking on any particular problem as such, because that may not, raise interest to everybody. But nevertheless, I will try to touch upon a few pertinent issues related to IoT security and specifically to protocols. Now, let's try to understand what has happened in the form of industrial revolution in last 200 years or so, or maybe last 150 years, or rather more than 200 years. So the first industrial revolution that has taken place, we call it as the Industry 1.0, was the main factor was steam power. With steam power, we could generate more power than what was available at that time. So what was the main power source? During early 1700, it was either human muscle power or animal power. So with the advent of steam power, many things got mechanized. Industries got created, railways came into picture. That eventually, after another almost 100 years, another big revolution came in the form of electricity. With the discovery of electricity, mass production started, assembly line in which products are getting, gets manufactured in a sequential manner, in lines, mass productions, that started. Electrical energy, which provided cleaner, much easier form of energy, and it was providing energy both at the home front as well as the industrial front. Again, we see another almost 100 years. That's very interesting that we have seen Industrial 3.0. That is about when with the discovery of, or rather with the manufacture of computers, automations, and electronics. So these three industrial revolution took place in almost 100 years apart. But suddenly Industry 4.0 came into picture in last a few years, which talks about cyber physical system. Now, this is something which created a lot of interest. What is that? Now, here the driving factor is multiple technologies. It's not like one single thing that has been discovered, but it is combination of many factors. First and foremost, easier connectivity in the form of internet. With 4G coming into picture and 5G is knocking at the door, we could connect not only our laptops, desktops, we could connect our mobile phones, and beyond that, we are now talking about connecting our devices, which are not specifically IT devices. For example, a smart TV, a smart refrigerator, a smart air conditioner, or any component you talk about in smart home, and it is much beyond home also. It has its own dimension in industrial aspects. We call it as an industrial IoT, where the physical systems, the physical devices gets connected to the IT world, and that thereby it leverages the benefits of the world, the automation of the IT world, and the physical device, the control of the physical device. Some of the example of industrial IoT is like power grid. These days, power grids are, a lot of our country's power grids are automated, and in many other also, whereby it can plan automatic load scheduling, automatic demand analysis, etc. Even if we talk about manufacturing industries, there are a lot of manufacturing industries which leverages industrial IoT, thereby increasing productivity and reducing cost. But then all that has happened with other factors, increasing the processor speed, affordable sensors, availability of bandwidth, availability of network protocols, all of that combined together. Today we are witnessing a industrial revolution, which we call Industry 4.0. And whenever there was an industrial revolution, there was disruptions. For example, in Industry 3.0, I would like to cite a few things which were disrupted by Industry 3.0. So e-commerce and all were the late entries in Industry 3.0. If anybody has taken a flight in 80s, I'm by the way, I'm an enthusiast of aeroplane. So I'll give you an example of aeroplane. There used to be several people inside cockpit in those days. At least you must, those who have not seen inside of cockpit. Those days, looking into cockpit was easy. It was not so much of security into it. So there used to be a pilot, there used to be a co-pilot, there used to be a navigator who actually tells that which direction the flight should go. There was a flight engineer to troubleshoot and whatnot. But those positions or those responsibilities has been removed by automation, which we call as fly-by-wire. That means the whole control or whole thing is managed by the navigation has been taken care by computer, the flight troubleshooting has been taken care by computer, etc., and which made things much more reliable. Similarly, Industry 4.0 is a disruptive technology, and it is going to change a lot of the ways, a lot in the way we actually live in a day-to-day life, or how the technology is at least leveraged. I'm sure a lot of definitions of IoT you must have heard about. So I do not want to go into long definition. To cut it short, it is the network of physical objects, for example, devices, vehicles, building. Think about anything. It need not be an IT device. So anything which connects, and it can be an embedded device, embedded electronics, software, sensors, network connectivity, which enables the object to collect and exchange data. We call it as an IoT. To cut the long story short, that's what it is. And there are a lot, you must have seen many diagrams which predicts by 2020 it's expected that or it is predicted that we have 50 billion smart objects. I do not know for sure how many, but we know it very much that it is very, very high. Considering the world's population is about 7.5 billion, 50 billion, which is like more than 4 times of the number of people. So it's a very large number. That means at an average more than 4 devices per person, and it's going to increase. And the slide is the source of the slide is Cisco. Okay. Now IoT has various names. Different companies has given different names. Some people say that it is machine to machine. So one of the difference of IoT system with traditional system is that the consumption of data generated by IoT devices are normally they are consumed by another machine or another device, not human being. For example, the consumption of email is by human being. I mean, at least till today, machines doesn't receive and send emails. But in case of IoT, let's say a smart refrigerator. So it has its own connectivity. It has its own logic, and the examples are many. I've seen a refrigerator demonstration whereby it says that it can interface with an e-commerce portal and check your inventory. And if some of your inventory falls below a certain limit, you can order. Okay. All that is possible because of sensors and actuators and integration of different subsystems. So you see, human beings are normally not there. They do not consume IoT data. Internet of Everything is called by Cisco Systems. Internet of Anything, there is another company called Data Nova. They are a big player in IoT devices, especially sensors. So they call it as Internet of Anything. And of course, Bruce Schneier, they already called it as world size web. And I would relate it to Skynet in Terminator movie. I'm sure many of us have seen that movie. So what everything deals with? It deals with people. It deals with, of course, we are there, we the people. It deals with process, that is the way of delivering right information to the right person. It also deals with things, which is physical devices, objects that are connected, and data that is leveraging whatever information or data available for more meaningful information. Thinking about IoT without thinking about data is something which is a very difficult proposition, or is simply not possible. These days, if we look around, we are witnessing many products which are developed out of data. You must be wondering, what is that? Can there be a product out of data? We must have heard products made out of metal, plastic, etc. But think about the transportation you use, Uber, Ola. They don't have vehicles, they don't have drivers, they don't have any infrastructure, they don't own the road. But what they are possibly one of the world's biggest taxi companies. And what they possess data about individuals who want to ride, data about drivers, data about vehicles, etc. And they have a system whereby they can process. And they have leveraged mobile phone as a source of controlling in a very intelligent way, controlling all these activities. So again, in one way you can think of that is also a cyber physical system. So how smart are these devices? Are they really dumb, or they are smart? They can be as smart as we can imagine. Now, with this IoT, technologies around, there is a new business model and there is a new ecosystem that has came into the picture. But at the same time, it adds to the complexity. Let's say whenever there is an IoT application, there is an application interface which connects to the application enablement platform, which eventually talks to the infrastructure interface, and which then application-centric infrastructures are provided. But then now with IoT coming in the picture, devices and sensors plays a large role in this ecosystem. And what are the complexity, or what are the components that adds to the complexity? Data integration of the devices, data from other worlds. The amount of data that are generated is also very large, because IoT devices are normally large in number, and they continually operate, keeps on generating data. So the way we look at data is different. Sometimes called as a big data problem. Analytics getting meaningful inference out of this data. If there is so much of or abundant data is available, let's say whole days temperature, air pressure, wind velocity, all of that are available. Now, with that, what should I do as a common human being? What I'm interested in is that whether there will be a rain in the afternoon, or it will be a windy day, or it will not rain. I will have to get insight out of this data and build some analytics. And possibly also when I actually understand this, I also want to control the environment or the cyber physical system. For example, if the weather is fine and there is no possibility of rain, I might launch whatever device, maybe some unmanned aerial vehicle, UAV or drones, to do some tasks, to do some photography maybe, or whatever you can imagine. So that control system is another aspects which also adds to the complexity. And comes the last but not the least is the application integration. The applications that are there in the real world that should be able to talk to these fancy sensors and devices. Otherwise, it's meaningless. For example, if we want to see weather, we will definitely not buy a weather sensor and put into Raspberry Pi devices and build a weather station for ourselves. What we will be interested in is to install an app on our mobile phone or on our laptop, which can give us weather information. But then from where the weather information comes? The weather information has to come with some integration from different platform. Now, what comprises of IoT network? Has two parts. One is IT part of it, information technology, traditional machines, computers, laptop, desktops, servers, network, all of that, switches, routers, etc. Plus operational technology. What are they? They are physical things. Okay, for example, a car. A car was never an IT equipment, or a refrigerator, a TV, a oven. So those were not operational technology. When you combine IT with operational technology, you get something called smart objects. What is smart object? What do we mean by smart object here? Which can decide something. Say, for example, let's take an example of a chemical plant. In a chemical plant, a reaction happens, let's say, at a certain temperature. Let's say 100 degree. Now, how to maintain that 100 degree? First, you start heating it, raise the temperature up to some level. And then when it reaches 101, 102, or it crosses, say, let's say 100, so you need to stop the heating element. And when it crosses, let's say 120, what you need to do, you need to start the cooling. Otherwise, things might melt, your equipment might melt. And if the temperature, again, after cooling, if it falls below, let's say 90 degree, then again, you need to start heating. So all of that, is simply a IoT problem. Let me give you, so I was of late interacting with Indian Railway engineers to build some of their devices and systems. Some of the interesting problems that came into picture. A railway is never an information technology stuff. So they have some pertinent problems. There's something called as brake binding. What happens that the brake, so by the way, every wheel in a train has brake. So braking happens in all the wheels. Now sometimes the braking system actually keeps pressing the wheels. They call it as a brake binding. Now they need to know whether that is happening or not. And it's simply not feasible in a running train that all the wheels will be checked. And how to check it? So, and you can check only after certain interval. So they have people, so after 2-3 hours or maybe every large station, they do it. But then continual monitoring is not feasible. So they are possibly, we are trying to leverage sensors which can actually tell us that kind of a problem. Then they have, like, they mention another problem called hot excel. So sometimes there certain metal parts gets heated up, and it gets heated up so much that there is chance of melting or even derailment. So again, you see, early detection of such hitting can possibly avert such situation, and proper action can be taken. So I'm just giving you an example where all IoT can fit. It can actually fit anywhere. Sky is the limit. You just need to open your eyes and think about it. So normally, if we talk about, uh, I remember like when we used to talk about sensor network, there used to be a common example, that mango ripening problem, that whether the mango is ripe or not in the tree, I will place sensor, and sensor, from the sensor I will come to know. And I used to say that no, I will go out and check whether the mangoes are ripe or not. So that was a hype thing. Similarly, in IoT also, there are a lot of hypes around IoT. Every single literature talks about smartphone, smart city and smart home. IoT is much beyond that. It's not only smart home or smart city. There are municipal IoTs like smart cities, smart grid, etc. Industrial IoT like connected factories, agriculture, logistics, medical IoT, for example, smart hospitals, electronic medical record, or diagnostics. With the current pandemic situation, the medical IoT has seen a paradigm shift, and it's becoming more and more acceptable. So what all that IoT can do, you can connect things, anything, any device you have, you can possibly connect it. You can control anything by actuation. You can gain insight. That means you can know what is going on, and based on all this information, you can take action. So that's in layman terms what IoT is, beyond all the hypes. So this technology there is nothing new as such, but many technologies which combines together to so the connectivity in IoT. If you talk about Bluetooth, Wi-Fi, cellular connectivity, or Zigbee, or any other connectivity, you name anything, they were there for quite some time. The control system is a pretty old, or rather pretty matured science actually, and my friends in electronics will tell more about control system. That was already there, right? Actuation was already there for at least more than a couple of decades. But then when all these combine together, that forms an ecosystem. That's the whole concept is new, that kind of ecosystem. So the tectonic plates are having a continental drift. Now, what is that continental drift is? There is convergence of multiple tools and methodology, as I mentioned. There are various technologies they are getting combined. So in one hand, dependability is changing. That means there are devices now which are large in number. Some of the IoT devices may not be very reliable. But then how we overcome that reliability problem? We try to leverage large number of IoT devices. At the same time, the trust has gone down because of divergence of conceptual model and the convergence of tools and methodology has led that there is a change in security posture. The more doors and windows you have in your house, possibly you are more vulnerable to security issues. Same thing over here. When you combine multiple technologies together, the weakness from all the technologies actually inherit to the new technology. And then while integrating, you add some more problems into it. So that's the continental drift. Now, what is the security challenge over the internet? We have enough of it. We have, spams, viruses. We have trust issues. We have, privacy issues. There are honeypots, and there are enough amount of devices and technologies that we leverage. For example, firewall, IPsec channels, IDS, IPS, SSL. So it's all broken into multiple pieces and we are stitching it together. And at that time, at the same time, we are talking about, combining multiple technologies into one. So that actually posing serious threats. There are new landscape in security, for example, zettabytes of data. Nobody knows how to deal that much amount of data, or at least it is very, very difficult. Then the data formats. Now, the data are stored in various formats like XML, text, RDBMS, JSON, many different formats. And we need insight from all of them. The asymmetry in cryptography, because these devices are such that you may not be able to implement a good cryptographic mechanism, or at least you may not have the luxury to use large number of bits crypto for building a crypto system in IoT devices, because they are normally low in power. There are issues of spontaneous and massive attacks that we have seen in last few years. The bad guys or the attackers are clever. What they have started doing is that instead of launching attack from traditional computing devices like desktop, laptop, servers, etc., now what they are trying to do is to leverage IoT devices. And there were some attacks happening earlier this year, which were launched using CCTV cameras. What has been done is that denial of service, and that is called reflexive denial of service. That means the traffic that has been used to launch that denial of service attack, think about it like it got reflected from these CCTV cameras, which are IP cameras. So these are IoT devices, they were connected, but then do you monitor the logs of CCTV camera? You never do that. Forget about CCTV camera, we do not look at the logs of our laptops. Only the core infrastructure, the servers, firewall, etc. Possibly somebody looks at the logs, others are not. So the attacker found it very easy. There are other aspects like in IoT devices, OS security is not the first priority. The first priority is that it should be very lightweight. It should be, it should work. It should communicate. So those are the priorities. The way when computer network for the first time came into picture, the protocols were designed to work. They were not designed for security, for security. Dr. Sujay, am I audible? Can you please confirm? Or anyone else?
Yes, yes, you are audible. Yes, you are audible.
All right. So please feel free to stop me anytime if you have any queries. So yeah. So I was talking about how these IoT devices are leveraged to launch attack, and that too in a massive manner. So IoT devices, just like IoT, the early protocols that were designed. Let me give you an example. The SMTP protocol, what we use for exchanging emails, believe me, it doesn't have any authentication mechanism. So if I want to send an email saying that I am sujay@makaut.ac.in, nothing prevents me. And I can send an email, believe me. Because it doesn't check the way I can send a letter saying that I'm Sujay, and if I post that letter in Guwahati also, writing my address, fictitious address, as Sujay of MAKAUT and such. Maybe let's say Salt Lake City, cluster number these, whatever. The similar way mails were designed. And then nobody thought that financial transactions, then, you know, serious communications, etc., will be done through these kind of, emails. They were like initially academic tools to collaborate, or like out of curiosity it has been developed, and they were initially leveraged for from academic perspective. Nobody thought at the when internet was designed that there should be an authentication mechanism for this. Again, another interesting thing. I'm sure all of us know DNS. When we say google.com, somebody has to say its IP address. The DNS server says that. Again, if I run a fake DNS, and if I say that google.com is my IP address, which is 1.2.3.4, let's say, there's no problem as such. Your device, if it listens to my advertisement, which I'm lying, it will automatically update its record and place in its record that, okay, Google is Firdausi's IP. No validation. Okay. Again, why it was not done at the time? It was supposed to work. It was not supposed to be a secure system. And the security mechanism in TCP/IP protocols, most of the network protocols are afterthoughts. That means initially the protocols were designed, they started working on it, and then eventually they thought of putting some security. And IoT is not an exception. IoT devices were also manufactured, and people are not even converging into one protocol, multiple protocols, multiple vendors, multiple different types of devices are there. And everybody is interested to leverage the boom in that industry to their own benefit. Somebody wants to earn money, somebody wants to earn fame, somebody wants to publish paper. All of that are happening. Okay. So IoT is again another such technology which is having similar problem. So if IoT, it is just yet another computer, and the issues are similar to computers, then why we should worry? We should be able to apply whatever knowledge we have in IT world for security into the IoT, and it should solve all our problem, right? So all all of the same issues which we have with access control, vulnerability management, patching, monitoring, etc., can apply. But think about it. Suddenly, a scale where your network doesn't have like a few dozen equipment, but rather you have 1 million equipment, and the entire game changes. How do you manage 1 million equipment? How do you patch them? How do you see their logs? Or how do you communicate among them? And even one device which is compromised out of, let's say, 1 million device can have serious threat. For example, it's easier that we say that, okay, we will put a sensor in the Indian Railways, every wheel of every train, which may monitor that whether a brake binding has happened. Okay. Now, think about like what will be the scale? It will be in millions. Now, how Indian Railway monitors those devices, that whether they are working or not. And even I can program those devices to send wrong data. And all of us know as a computer programmer that I read some value, inside IoT devices, there are programs only. So I change the program. The program was supposed to read the value and send it. I let it read the value, and let's say it is supposed to sense the what is called the distance between the braking system and the wheel, and it is supposed to send that distance, and maybe this distance is in millimeter, or maybe fraction of a millimeter. Now what I do, I always read and I keep sending. I change the application logic and I keep sending always that 2 millimeter or 1.5 to 2 millimeter randomly. I keep on sending the values. Everybody thinks that it's all fine, but actually things has got stuck that might lead to accident. Okay, so leveraging things are easy, but managing their security, because these are physical things. Think about those smart vehicles that are coming into picture. If some attacker finds one loophole with these vehicles, they can let vehicle collide and they can create a massive problem for any city or any person or any driver, etc. So any compromised device can be a foothold in the network. And I talked about variety of protocols. See, in the physical layer, the protocols are more or less known to us. These are Wi-Fi, WiMAX, Bluetooth, NFC, LTE, etc. And of course, some IoT specific protocols like ZigBee. In the link layer, their specific MAC is there. The radio transmission, it deals with various protocols. If you come at network layer, the interesting part is that these devices cannot be addressed using IPv4 addresses. Reason, we do not have that many IPv4 address. Now, the solution is to use IPv6. But how many bits are there in IPv6? 128-bit address and a small sensor, calculating routing information, calculating neighbor. Those who know a little bit of IPv6, these are expensive operation. So there is a 6-low means adaptation layer, which you call as 6-low PAN. So there is another, complexity that is coming into the picture. In the transport layer, it is UDP and mostly not TCP. Again, what is the reason? IoT devices are not supposed to be online always. They are on and off devices. They sometimes might have connectivity, sometimes might not. And those kind of messages, what they generate, is more suitable to be carried by UDP rather than TCP. Because end-to-end connection in using transport layer in IoT system is difficult. If we talk about, and there are other variety of protocols like MQTT, etc. Then at the application layer, the way we normally deal in web scenario is HTTP, but here it is UAP, DICE, ACE, etc. So we can see that all network layer protocols are there. Along with that, we have many more like 6LoWPAN, COAP, DICE, RIoT are coexisting. And when so many protocols are there, there are more chances of things getting compromised. If the number of lines of code is more, it is a known science that the possibility of attack is even more. The more the intention is, possibility of attack is even more. So the major flip side is a security challenge. And it doesn't finish over here. IoT is an evolutionary technology. If we look at the evolution of technology, we had hardware. We built the computer system, possibly in 70s. After that, we built the operating system. Then we built the network. Then we built the web and World Wide Web and whatnot. Then we got the mobile devices, and then we have the cloud computing, where we outsource our storage, compute services to some third party, and we use these infrastructures as a service rather than owning it. And then IoT leverages all of this. IoT has operating system, it has hardware, it has network, it can connect to web, it actually has mobile-based technology, it connects to cloud. So the challenges of all these platforms are also applicable in IoT system. Okay, so why it looks so bad then? Why not we ban the IoT devices altogether? Then let's not use any more IoT devices. So the breakers or the bad guys, they have a long history of having robust tools and technologies to break into other people's system. These days, there are automated network attack tools are there, and as low as by paying $1. And then also you need not have those tools, you need not own those tools, but they are available as a service. That means you can rent it out, rent those tools which are hosted somewhere on the internet, and using those tools, you can exploit IoT resources. This also tries to exploit the most segments of the IoT stack, which I have shown you just now. So they try to exploit the IoT stack. And then there is another problem with IoT device. Normally they are field deployed. That means it is not inside your server room, which is physically protected, or data center. It's not like that. Think about some monitoring device to monitor our international border. So they will be deployed in the border, and intruders or the bad guys might have physical access to them. Okay, normally a hacker, what we call, an attacker doesn't have physical access to our machine. They try to logically or over the network, they try to harm those computers. But here, physical access is also available, which makes it even tough to protect these devices. And with the builders, those who try to secure the system, we are still search for some toolkits which can save us. And we do not have enough of proven methodologies. And we also looking for successful model. In security scenario, at least have a successful model that, okay, this is the way to do. And if you put these are the devices and these are the algorithms, then you will be secure. It's not available. Any question? Is there any question? Anyone has a question? Okay. I can hear some noise. I would appreciate if you can put on mute if you do not have a question.
একদিন তো রোজ দিন ঘুমাইতো
Looks like some television noise or something. Okay, so what is the result? Dr. Sujay, you can actually mute all the participants. You have control, to mute any participants. Okay, looks good now. It happens, no problem. So working from home has its own challenges. Builders, actually, we try to cobble together components and we try to build fragile full stack solutions, and we do not have any visibility into security and attack surface. means what all components that can be attacked, we do not know. And the attackers, they have a filter. That means they can almost do anything. Dr. Sujay, how much time I have? I've started it around.
Sir, you have almost half an hour, and you can go on to almost 7 actually.
Okay, perfect. So maybe I will speak for another half an hour, and then I will take up the question.
Yes.
Okay. Thank you. And the miserable track record of IoT security, if we look at the Mirai botnet growth in 2019, basically there was a heavy growth of botnet called Mirai using IoT devices. Then there were Hickory hardware smart deadbolt threat. What is a deadbolt? Or we sometimes call it as a tower bolt. I mean, in Hindi, possibly we call it chitikni, and in Bengali we say chitkari or something, which we we normally use at home to lock our doors from inside. So there were like there is a company called Hickory Hardware, and they have some deadbolts. Those those deadbolts were smart, but then there were security threats, and there was a massive disruption, robbery, etc. Google Home and Alexa had their own security breaches. I know you must be using them. What they have done is that they have leaked certain conversations from certain people's home when they were not supposed to they were not invoked, or they were not supposed to do anything. I'll tell you one very funny thing. Many people, actually ignores the IoT security threats. They think that I have a very, small primitive system. What an attacker may be interested in that. One was like, hacked baby monitor. Baby monitor is something like, it's like a large basket where there are automatic toys and cameras, and you can show them videos. So the parents who are working, so they actually use baby monitor to monitor their kids at home, infants specifically. And they need to monitor it from office. It was connected. So suddenly there was a report that whenever they put babies into this monitor, the baby starts crying. So what has happened? Then after investigation, it was found that some attacker actually compromised those devices, and they show scary videos to the babies. Okay, so that's how the IoT devices, a compromised IoT devices, can make life miserable. So IoT actually expands the security needs. How it does that? The first and foremost thing is that it has increased the attack surface. That means, what does it actually mean? That the attackers has now more things to attack, or more options of attacks. So the risk naturally has increased. And the threat what these IoT devices posed, all the attackers posed through IoT devices, they became diverse. Earlier, there were like a few medium through which security could be compromised. Right? It was like my email ID, my web presence, my websites, my application, my laptop, my desktop, etc. Now, think about it like your home's HVAC system, heating, ventilation, air conditioning system, or power grid, or even transportation system. Think about the school buses, which uses GPS for, uh, you know, what is called tracking the buses. And parents actually look at those GPS location of the bus, and they normally receive their kids. Somebody can fiddle with these GPS devices, which is very easy to do, and again create menace for the parents and the kids by giving wrong timing. So the threats are very, very diverse, and the impact is high, the risk is high. And we need remediation. That means we need remedies very quickly. And how to get those remedies? We need to have secure protocols to deal with such situations. And how does the secure protocol comes into picture? We need to have regulations. That means laws. Unfortunately, the last three is still taking time and it is under development. So it has both good and bad part. The first part is that the whole business is risky. Second part is we academician has some scopes to contribute here. So IoT connectivity options now leads to converged or managed networks. There is a resilience at scale. The scale is very, very high. And distributed intelligence. That means intelligence is now available at many IoT nodes rather than centralized intelligence, what it used to happen earlier when, in traditional systems. And then the applications which are there has to be enabled in such environment. So what can breach an IoT network? Answer is simply what can't. Everything can breach an IoT network. Billions of connected devices, secure and insecure locations. Security may or may not be built in, not owned or controlled by the IT. That's very important. Normally, if we have some infrastructure, let's say, whatever infrastructure MAKAUT has, I'm sure there are some system administrators. And whenever we have problem with any of these devices, we go and contact the system administrator. We call it as IT departments mostly. And they are supposedly knowledgeable in this aspect. They look at it and they figure out what has happened. But IoT devices are not owned by the department's IT, IT department of an organization. They are owned by other departments because they are application specific. But the data actually flows through the network infrastructure. So you can see potentially anybody can try to, or anybody have the potential to compromise IoT devices. Now let's look at the kind of attacks that are possible on IoT devices. First, let us look at physical attacks. Being the devices are accessible, physically by the attacker, what they can do is probe. That means they can connect some wires and try to get information out of it, or try to reverse engineer. That means try to break the system and know how it functions or how it is designed. and then possibly doing something destructive. Or at least what they can do, they can prevent the device from giving correct reading. Just I mentioned about the braking issue of Indian Railways. If the attacker can just prevent the device to send the data, then also he is successful. You will not know that there was a problem. Then comes side channel attack. What happens in side channel attack? That you have some neighbors, which may be some devices, etc. And these neighbors actually can monitor whatever that is going on your device. They may be doing the timing analysis from the same network. They might see that when you are transmitting. All the okay. Then, am I audible?
Yes, sir, you are audible, but sometimes it is getting breakdown due to network. So please continue, sir. It is okay now.
Okay. Okay. So whenever it breaks, let me know.
Okay, sir, sure.
Okay. All right. So the side channel attacks, it involves timing analysis, power analysis, fault analysis, electromagnetic analysis, etc. Then there are attacks out of the environment, dust, then storm, wind, all of that, and from the environment also there are various attacks can be launched. Then comes cryptanalysis attack. As I mentioned earlier, these devices has limited capability. So with this limited capability, they cannot leverage very high cryptographic, cryptographic algorithms, which are very the cryptographic, cryptographic system. There are many known attacks like ciphertext only attacks, known plain text. All these attacks, these are first attacks. If you look, over the web, you will. Those who are not aware, you can know what they are. Then comes software attacks. Many computer devices, IoT devices are also susceptible to virus, Trojan horse, logic bomb, worms, denial of service, etc. In the network attack, the way IoT devices has to send data over the network. So all attacks that are prevalent for network are also prevalent for IoT devices, like monitoring and eavesdropping. That means one can try to see in the network that what data IoT devices are sending.
Sir, your voice is getting break, sir.
Try to. Is it breaking now? Is it better
yes,
now?
Yes, it is now. Yes, it is now. Okay.
Okay.
So please.
So denial of service attack, then node malfunction. They can capture a node, or they can actually use some mechanism for node outage, because IoT device will have limited power, mostly powered batteries. from the network, they can create situations where these nodes are bound to transmit their power, and eventually they will run out of power. Okay. False node, they might insert some false node or replicate your messages or poison your routing protocol or routing table, etc. All those attacks are possible. So the list of attacks in IoT security paradigm is relatively large. Give me a moment. Okay. And with these attacks, what can go wrong? Think about like transportation system, military, vehicular network, weather, smart home application, supply chain, health, IoT, agriculture, livestock. All of them can suffer from such attack. And the implication of IoT-based attacks sometimes process multiple times than of traditional attacks on IT infrastructure, because these IoT devices also involves physical systems, which are normally not hampered when an IT system is compromised. But here, it has the potential to damage physical systems and even human life. Okay, so some of the attack examples that I would like to put forward, that at the preliminary stage, what can be done? Hacking a node, that means compromising a node, or an attacker might try to implement a malware, or inculcation of malicious node. That means put a node which doesn't belong to the owner and try to behave like a normal, but do something mischievous in between. Deploying equipment for intrusion, or try to deploy some equipment which will intrude into the network or in the system of these devices. So what are the attacks they can launch? Packet flooding. They can send enormous amount of packets, an attacker can send, and that might flood the entire network. Vulnerability attack. Any IoT devices, if you list, if you search by an IoT device name or serial number and just search in Google that what are the attacks or what are the vulnerabilities are there or what are the attacks that are feasible, it lists them. So the attacker need not be super intelligent guy. He can just leverage that information and find an attack vector, means a payload to launch that attack. And this packet flooding and vulnerability attack can have a serious implication on availability. At the physical layer, an bad guy can try to jam the network. Jammers are pretty cheap in nature, and if you use jammer, then the device won't be able to transmit any data, because most of the IoT devices won't be connected by a wired network, but it will be a wireless network, and which is susceptible to jamming or prone to jamming. Similarly, black hole attack, you know very well. Then selective forwarding. The attacker may choose to selectively forward some messages and some are not, and which might have a problem with integrity or the message integrity. Then Sybil attack, through which the payload can be compromised, which might have an impact on confidentiality. So that way, if you look at the CIA paradigm, confidentiality, integrity, and availability, which is the basic building blocks of information security, what to do? CIA, the confidentiality, integrity, authenticity. Along with that, these days there are a few other factors which are important. They are availability, access, reliability, and repeatability. Availability: my IoT device should be available. at any cost. And access, I should have the access to the device. It should not be like someone should be able to block my access to the device. And reliability, when the device sends some messages, how reliable they are, or repeatability, whether I should be able to, whether I'll be able to repeat or again reproduce what has happened. So historically, it joined heterogeneous networks and abstraction of a layer with two abstracted transport services. And it was developed towards an ubiquitous network technology. And internet became the network and IP became the de facto protocol. Now, these hosts are, remember the device versus hosts. If we look at it over the internet, I mean, IoT systems, we have devices, but in case of computers, we call them as hosts. Now, here hosts are addressed, but then there is a reverse also. In RFID, the readers are hosts, not the devices. Devices are named, but in RFID, the tags are the devices, whereas tags doesn't have any power. Host needs to be reachable, but then in IoT, you have semi-permanent addresses. Routing capabilities are deep in the network, like DNS or border gateway protocol. So then what all security challenges we can see? The devices not reachable many times. Devices can be lost or stolen. Devices are not by default crypto engine to support good cryptographic mechanism. Devices has finite life. That means after some time, the device's life ends. And what does that mean? All the cryptographic keys that are inside the devices should be destroyed, or they should have a lifetime after which they are not supposed to work. And devices are transportable, and it can easily cross borders even inside a pocket, inside someone's pocket. So these are not bulky devices. So all of these reasons actually pose serious security challenges. And these devices also needs to be recognized by many readers. And what does that mean? What data is released to what reader? That is also important. That means authorization. So what are the security works that are prevalent in Internet of Things these days? In the assurance segment, how to analyze risks that are associated with IoT systems. The analysis of devices, how can we analyze the device to figure out what security threats it can pose? The crypto capability and export analysis. I'm sure many other speakers must have spoke about it. Like what are the crypto systems that can be built around and what can be leveraged? The security objectives, that means privacy protection, identity protection, traffic analysis, protections, etc. should be built in. And identity and identifier management. That is another. So the next, beyond assurance, next what we need to look at is identity and identifier management. It means all users or all the stakeholders who are part of these IoT subsystems, and sometimes they may be from very different organizations, having different user credentials. For example, I'm Firdaus and I have a credential Firdaus at the IEEE.ac.in. My credential will not work in the university, or called MAKAUT in short form. It will not work over there, and vice versa. For their credential is not going to work in my organization. But if we have a common IoT subsystem where both of us subscribe to, we have a common point where we are generating or where we are reading data. So we need to separate the identity and the identifier. and we need to manage that identity. So I'm coming back to the slide with which I started with this, that how can we have a secure IoT architecture with IT, information technology, plus operational technology. And you remember we have devices and sensors, and we have many different challenges of data integration, big data analytics, etc., etc. So now the services is expanded. It is right from application and business innovation to device and sensors level. And the security is built in layer wise. So let's say at the device and sensor at that level, it is end-to-end data encryption. That is one way of protecting security of the the IoT system. But how to do that, again, it's not a very established work. Then at the higher level, device level security or anti it is better to get destroyed rather than revealing data. That means no one should be able to tamper it. Physical security, the device should be physically secure. And then network and perimeter security at the network level, it should be secure from all outsiders. And cloud-based threat analysis, it means IoT devices normally prefer storing data on the cloud systems. So we need to have a cloud-based security and threat analysis protection mechanism to deal with that situation. This information technology and operation technology are inherently different. In IT world, any host can actually connect to any, but in case of operational technology, it is hierarchical. In case of IoT world, normally the communication is hierarchical. The sensor actually talks to the gateway. Gateway actually sends the data on their behalf. The network posture of IT devices are confidentiality, integrity, and availability. That means the first and foremost is confidentiality, integrity, and then the availability. Network posture of IoT or operational technology is different. First is availability. My system should be available. Second is whatever I'm getting, it should be correct. That is integrity, and confidentiality is third. So we can see that there is a change in the priorities. Then the security solution is, in case of IT world, is cyber security and data protection. In case of, obviously, the same thing applies to OT, but there is more to it, like physical access control and safety. So in case of IT environment, the response to attack is normally quarantine. That means you detach that particular applications or particular host from the network, or shut down and mitigate. Unfortunately, in case of IoT system, it may not be possible. The example I gave you, a railway system, if there is a problem with some of the sensors in a railway operation, we cannot say that tomorrow there is no train which will operate. Never stop. Even if there is a breach happening, you will still have to live with it, and you will have to mitigate the risk that is arising out of it. So, measurable track records that continues, I won't even go into it. But then with all that hopeless scenario, there are some ray of hope. There is a project called OWASP. Well, anybody knows what is OWASP? Anybody heard about? You can unmute and tell what OWASP is. That's okay. OWASP is open source foundation for application security, which is an open source initiative for protecting web application. And what they do, they release advisory. They tell that what are the most relevant threats which are there for web application. So WASP have started a IoT project. Now they publish the threats that are related to IoT, and also they tell what are the ways to mitigate it. The attack surfaces, the vulnerability risk, and reference solution that are there. It aggregates the community resources, it provides guidance for developers, and it also provides IoT specific security principle. IoT must visit. So another thing, please note, being IoT is an evolving field, the threats that are there in IoT that also evolve. This is the WASP IoT top 10 list. Just have a glimpse. Insecure web interface was the top one. Insufficient authentication authorization was the second. Insecure network service third, followed by lack of transport encryption, followed by privacy concern, insecure cloud interface, insecure mobile interface, insufficient security configuration, etc., etc. But if this is the latest one, see here the number one has changed. Now it is weak or guessable credential or hard-coded password. Many of the IoT system has password which is hard-coded inside them. Then insecure network services came second. Third is insecure ecosystem interface, and so on and so forth. Okay, they keep on changing. The latest one as of now is WSP IoT top 10 is of 2018. Most likely in 2019, sorry, 2020, later part of 2020, there should be another top 10 that that should be available. But we should keep an eye on how the threat landscape is changing in IoT systems. So what are the principles of IoT security? Always assume a hostile edge. That means beyond your sensor at the edge level of the network, you never assume that it is secure. Think of it as a hostile. Test for scale. See if it scales or if thousands of devices works. Remember, Internet of Lies. The way Internet of Things, there is an Internet of Lies. The bad guys always lie about your data, your network, your availability, etc. And exploit autonomy. Expect isolation. Protect your uniformity, and encryption here is tricky. By now, I'm sure many speakers have talked about it, and it is difficult. And system hardening is one of the key. So limit what you can. Do not do something which you can't or which you can't manage. Look at life cycle support. Do not just deploy IoT devices or or do not work with the IoT system which just works, but look at like IoT whole life cycle. Data in aggregate is unpredictable. Many times when you aggregate data, it may not be predictable. Remember, and plan for the worst. Always have a contingency in plan, and the long haul plan is better. And attacker targets the weakness, so always try not to keep any weakness. I will tell you, once at midnight, I was configuring an instance, cloud instance, at AWS cloud instance. And I did a pretty hard work, and at 3 a.m. I slept. I was very happy. I could do everything what I wanted. In the morning, when I woke up at around 6 o'clock, first thing I logged into the, of course, after brushing and all, I logged into the system. And what I found that Being that was a test system and I was just configuring it, I kept the password a very primitive one. I can tell you, I kept it ABC123. And next morning I could found that some attacker actually took control of that. They erased most of my details, they compromised the machine, and they launched attack from that machine. So never ever think like I am just testing on that machine. See, I didn't have any critical data on that, but my entire night's work was wasted because somebody did that nasty thing. And think about, also do not think like these attacks are launched by human being. Many times these are automated softwares which keeps on searching for such soft targets, and they try to launch attack on those targets. Use NS2N authentication, that means as many people are there and when devices are there, to use that much of authentication model. I think framework assessment, I will not talk about it. And some edge considerations we need to look at, like whether all our communications are encrypted, whatever data we are storing, are they encrypted? How is the logging performed? Whether logging is properly done or not? Is there an updating mechanism? Are there default password? Or what are the offline security features that are there? Or is transitive ownership is addressed? At the gateway level, what you need to consider that is encryption interrupted in the gateway level, or if there is a replay or denial of service, or is there any local storage, and if it is there, then if it is encrypted, is there any anomaly detection capability? Is there any logging and alerting service? In case of cloud consideration, you need to have, so IoT always have a cloud part or cloud tail attached to it. So at cloud level, you need to look at like whether there is a secure web interface, whether there is a data classification, segregation, whether there is a security event reporting, how the third-party components are tracked and updated. Is there an audit capability? Is there an interface segregation? And if last but not the least, is there a complex multi-factor authentication is allowed? At the mobile level also, there are considerations, again, very similar to all those. What countermeasures are in place for theft or device loss? Does the mobile authentication degrade? Is the local storage done securely? Whether there is an audit trail, can mobile be used for enhancing authentication for other component? And I will stop here. With some final thoughts that privacy is a real issue. The regulations are evolving and consumers may still face security problem, and security can be a differentiator while IoT products, whatever new IoT products are coming into picture. And that is why we academician has a good scope in contributing. And if we contribute well, possibly such kind of work might get noticed by some industry, and we might benefit from both recognition and publication, or even commercial gain. So all of that are possible in the form of patents, copyrights, product building, and of course good research publications. Some of the, if you notice that the IoT journal has a very high impact factors. IoT articles are very well cited because this is a very evolving field. But at the same time, let me tell you, this is a very, very fast moving field. Every day something or the other changes. So keep an eye open and look at the opportunities. I am open for discussion. If there is any question, you can put it into the Q&A, or you can unmute and ask a question.
Thank you, Dr. Amit. Hello. Thank you, Dr. Amit, for your such a what I say, knowledgeable and interesting speech So still now there is no question, I think. Prem Kumar, hello.
Yes, we are not finding any questions from the participants. So we request to the participants that if you have any questions or you want to know any information regarding the topic, please post it in the chat box or in the question answer section.
So
Any question is fine. Please do not hesitate to ask any type of question.
actually, I have a question from my side.
Sure, please.
Sir, actually, this is very beginning question. Actually, beginner's question. I can say that software updating is one of the what I can say a fundamental security practice for any kind of devices. So, so how much it is difficult for updating software in case of IoT devices? Because sometimes it is the at the end of the age. Yeah, yes, sir.
Yes. Very pertinent question, very interesting question. How difficult is to update the software in IoT devices? I would say very difficult. Why so? Think about one IoT device which is very common day to day. We use it is like POS machines. Okay, the payment machines of where we swipe our cards. I have seen once like how the software gets updated on that swiping machine. The links, I mean, most of the swiping machine they work on GPRS. They are very slow, and it takes time to update. The other problem is that how do you scale? Say today, if ICICI Bank wants to update all its payment system devices, it will take a lot of time. There's a problem of scale, there's a problem of connectivity, and the other problem is the device is not in your control. The device may be off, it may be turned off. So basically, there are a lot of research that goes on. Again, for efficiency reason, let's say this payment system has a software which is couple of MB, 2 MB. And normally these kind of devices, their operating system, application, everything is a monolithic design, and everything resides together. Now 2 MB, if you want to transmit over GPRS and that to let's say 100,000 location, you know what the problem is. Now what can be done? Can I securely update only the portion of the binary which has been changed? So there are a lot of research that goes on there. Okay, we try to make some contribution in it. You can read it
Yes.
While I was at IIT Guwahati. But this is a very open field, very fluid, and there are enormous amount of challenge. So there is not this. I mean, I do not have a single short answer which I can say.
Yes.
The way to do it.
Yes.
But
yeah, I can understand because sometime during that updating the software, we need to reboot the system or shut down the system. So for that kind of thing in the IoT devices, it is very much challenging actually. So shut down the without shut down the device, if we need to update the device, so that is very always a difficult thing actually. Thank you, sir. Thank you.
okay, so I have like 3 questions right now. Abhijit Bose has a question: IoT security with blockchain, if I can focus.
Yes.
Well, there are discussions around IoT and blockchain, but then we need to understand that why blockchain is used. Blockchain has its own merit. It's a very good, very nice thing, but it has its own scope. Everywhere we should not use blockchain. Blockchain is an immutable ledger, basically. That means once you put a block into that ledger, you cannot change. It is immutable. Okay. Until and unless a proper transaction is done on it. Now, the other thing is that it doesn't require any central authority. anybody can actually check or prove the authenticity of something. And third property, it is completely anonymous. Now the question comes, do we require these three properties in blockchain? If required, yes, we can leverage blockchain on it. But at the same time, look at the computational cost a blockchain will have. It is a very compute intensive thing. And there are IoT systems where you can think of using blockchain, for example, smart grid, which makes sense. But for a weather monitoring system, maybe it's too much. To kill a mosquito, you are firing a cannon. And if you are further interested, although I didn't have any agenda to discuss blockchain today, we have a few papers on blockchain. You can go to Google Scholar, search my name and find out. Last year we have published in BSCI, that is one of the reputed blockchain conference, where we proposed a smart grid blockchain system for smart grid. We have proposed this year a document management system for smart grid. A few 3-4 publications at least you will find. You can look at it, or you can look at other publications in this area. But to be honest, let me tell you, I have not seen any real applications or real device, IoT device, which uses blockchain yet. But academically, of course, we can look at it. I hope that answers. Now, next question is from Nimisha. How do we create a DOS attack for a Raspberry Pi or any other IoT devices for experiment? Okay. It is same as creating DOS attack for any other device. A Raspberry Pi device also, if it has a, I'm not sure which type of Raspberry Pi device, if it is a Pi 3 board, then it has a LAN interface. If you are connected to LAN, you can, depends what kind of denial of service attacks again you want to do. If you want to do a denial of service attack in terms of unavailability, you can do an ARP cache poisoning by doing an ARP broadcast. Or if you want to overwhelm the device with traffic, you can do reflexive denial of service attack. There are many tools which can be leveraged. And I recommend that you use Kali Linux, and there are many off-the-shelf tools available installed. You need a never ever launch an attack on a live system. Next question is from Shantanu Bhadra. How IoT security and reliability plays an important role in smart grid control? Well, smart grids are nevertheless IoT devices, and the IoT security, they are IoT, so their security and reliability has to be there. Otherwise, our cities will be out of power. If somebody takes control of those devices, they can shut our power down. Or think about it, it can be life risk, like somebody can manipulate the voltage level and the lines which are carrying home electricity to home, which is like now normally 220 volt. If they can fit very high voltage in those lines, things will burn out, right? So they have there are vendor specific mechanism to deal with that, and there are open world mechanism. Again, the paradigm of CIA, access control, authorization, all that plays a role. And again, we have some papers around that. You can read it out. Also, access control is one paradigm. See, at a smart grid level, to do something, one needs access. It won't be like without a password or without a protection mechanism. Definitely with a protection mechanism. So normally authorization related attacks are launched. So if you have a good authorization mechanism in place, then it can help. But again, these are there are open research problems in this area we can easily look at, and I'm open to discussion on this offline if you are interested. There is one more question from the same gentleman, Shantanu Bhadra. How IoT security and reliability plays important. Oh,
Same
okay, this is
question.
the same question. So I have answered it. Yeah. So I think it just
So
pasted twice. So yeah, so mostly the questions are answered.
yeah.
If there is anything.
So thank you, Dr. Firdaus Ahmed. Actually, I have actually mistakenly skipped the portion that is about your information, bioinformation. So, uh, uh, so, so taking from your permission, actually, if I go through that information at the end of the session, then it will be then all the participants will be know about it little bit more actually. So,
that's okay. Okay, Dr. Sujoy, I already mentioned and it's available on the website.
Okay. So thank you, Dr. Firdaus Ahmed. And actually, we expect from you that in future, if it will be possible from you to physically present in our campus and give such a nice and knowledgeable speech, that will be more benefited from the for students and as well as us. Uh, so we will expect that in future we will get you and you will present in our campus physically and and give such a wonderful speech to us and all the participants actually.
Thank you. I have been to your campus at least 2-3 times, and I love your campus. And I have many friends over there. During my interactions, many faculty members, and good to know you, Dr. Suja, as well. And I'm sure in future someday, let the pandemic be in control, and there are vaccines around. We'll meet in Kolkata.
Have you came to a new campus actually? That is in Horingata.
Not yet. I came to.
Okay.
To old campus.
That will you will enjoy that more. That is more bigger and more. You can enjoy that campus also. Okay.
Sure.
Okay. Thank you very much from all the organizing committee member, and hope we'll meet you very soon. And thank you again for your nice presentation.
Thank you. Thank you very much.
So with this this day of session again next day from 4 p.m. That is the last day of our faculty development program. Hope all the participants will be meet at the last day. Thank you all for patiently hearing the session. Thank you all. Thank you all the participants. Thank you, sir. Thank you all the organizing committee member.